All right, so last lesson. This is just general form of a linear equation. This one's not going to be too bad. It's all the same stuff again, right? You guys probably getting the gist of this. There's just these different forms of the equations, and then we do some algebra to rewrite them in different ways, and that's kind of it, right? So, all right, so the ones we've gone through would be, slope intercept. That was last lesson. We've done slope point form, right? And well, really, so this first one too, slope intercept. What would that be good for? Well, that'd be good if you wanted the slope or the y-intercept, right? What would the slope point form be good for? Well, that'd be good if you had the slope and a point, right? You'd put it into that one. They're all the same though, right? And then the other one we've done is standard form, right? So that was this one. And then the new one is going to be general form, and it really looks a lot like standard form. This one is just ax plus by plus c is equal to 0. So with standard form, all it is everything is on one side, and we just have it all equal to 0, right? So standard form, just for review here, was
that's general form.
Or sorry, did I say standard? Yeah, general. Sorry, yeah, general. So ax plus by is equal to c. That one there was standard, and now this one's general. Do you guys see how they're really similar, that the c just moves over?
Yeah.
That's the only difference, right? We're just getting it all equal to 0 on one side instead of having that c on the other side. So
what's the other one called? So it's standard and
general. And these are on your formula sheets too, and they actually have them labeled, so you don't even have to memorize them, right? All right, let's do some questions. So again, you guys can use those. All right, so the first one says, write each equation in general form. So we just need to have everything over to one side and equal to 0, right? The only issue is, in general form, just like standard form, we don't like the fractions, right? Do you guys remember what we did to get rid of the fractions, that little trick there?
No, we just added 2 at the top.
Yeah, and that was when it was over 2, yeah.
It's 4 now.
It's 4 now, so what do you think will happen now?
Go with the 4.
Right. We're just going to multiply everything by 4. And just notice why we did that. The only reason we did that was to get that 4 out of the bottom, because now 4 divided by 4, they cancel. Right? So that's still the same equation because we did it for every term. But now when we write it out, it's going to be 4y is equal to, don't forget the negative. We didn't do anything to the negative, right? So it's still negative 1x, or just x. And then plus 3 times 4 is 12, yeah. Okay. Now, again, so general form was ax plus by plus c is equal to 0. Now, like I said in the last one too, to be technical, we should have our x term in the front, and it should be positive. So I'm going to bring this x term over to the other side to make it positive. Okay, so I'm gonna bring these ones over there. So we'll add x to both sides, so plus x. So we've got x plus 4y is equal to 12. And then what's the very last thing you'd do there? Yeah, we'll bring the 12 over too. So we'll just subtract 12. So we end up with x plus 4y minus 12 is equal to 0. Yeah, sorry about that. All right, next one. Oh, sorry. Okay, next one. I'm going to write it again a little higher so we have more room here. So y plus 2 is equal to 3 over 2 x minus 4 in brackets. What kind of form is that in, by the way? No. Point, slope, yeah. Well, just as a bit of review, what would our point be?
X minus 3.
So remember our point was this one and this one, right? So, and do you remember how it was like the opposite of the signs? It was like our little trick there. So this point would be at the point 4 comma negative 2. And it would have a slope of 3 over 2. Yeah? Okay. Anyway, bit of review. All right, so this one wants to put it into standard form. Well, none of the forms I have on my page, well, I guess I shouldn't say none of them. This one does. But the other forms don't have brackets in them, right? So I got to get rid of those brackets. So we could be like, okay, I know what to do. We're going to just distribute that in there. That would be fine. Sometimes that can get a little bit confusing, right? Because now we're multiplying a fraction into it. We can actually make this a little bit easier. Why don't we get rid of that fraction right off the bat?
Can we still do that, like, times everything by 2?
Yep. Yeah, we can times everything by 2. So I'm going to multiply this by 2, this by 2, and this by 2. Right? All of those by 2.
What about the bracket?
What about the bracket part? Good question, right? So why didn't I multiply this by 2? Right? Like maybe that one. Yeah, well, yeah, because remember, when I've got 3 over 2 times this, it's actually already being multiplied by both of them. Right? I don't need to multiply by again because this is being multiplied by both of them right now. So I only have to multiply like this front part, the coefficient here, by 2. Make sense? And that'll get rid of my 2, and then we'll write it all again. So we've got 2y plus, and then 2 times 2 is 4, is equal to 3, and now just x minus 4. It always seems a lot easier when there's no fractions, right? So what would you do now? Yeah, we got to get rid of those brackets, right? So let's get rid of those. We'll distribute that. So we'll write it all again. We got 2y plus 4 is equal to, and then 3 times x is 3x. 3 times negative 4 is negative 12. Okay, this is looking good. Now, like I said before, we want it to be ax plus by plus c is equal to 0. Remember how the a should be positive, or sorry, the a values here should be positive. So we want to keep our x value positive. So as a bit of a strategy, I'm just going to leave my x there because it's already positive. So let's bring these ones over there.
Wouldn't that change it to negative?
If I bring these over, it'll make those negative, but this one will stay positive.
Yeah.
Yeah. Okay, so let's bring the 4 over first. Let's get rid of that one. So we're going to subtract 4 from both sides. So minus 4, minus 4. So we've got 2y is equal to 3x, and then negative 12 minus 4.
Negative 16.
Yeah, negative 16. And then we're almost there. We're just going to bring this 2y over to that side. Really by subtracting it from both sides, but if you want, we can just bring it over. So that's 0 is equal to, and I'm just going to put it in the right spot. This will be 3x, and I'm going to put the 2y in here. Minus 2y minus 16.
And you're allowed the minus, like the subtraction, right?
Yep.
It's just the x factor.
Yeah, exactly. It's just the x that's supposed to be positive, right? These two can be negative. Yeah. And again, it's fine that it's not written the exact same. This was all equal to 0. Mine's 0 is equal to all this. That's the same thing. Yeah, so that's fine. All right. Let's do this one quick. So show that the following equations all define the same line.
Can we actually do the graphic one?
All right, so if we wanted to figure out whether or not these were all the same line, it's not great. Well, if you can show that they're all exactly the same, right, that you end up with the same equation in the end, then we'd be good to go, right? So we could do whatever we wanted here. I could change, like, you know, this one into general form, or I could change these ones into standard form. It actually doesn't matter. As long as I can show that they are the same in whatever form, then we're good, right? So why don't we, to make life easy, these two already look really similar, don't they?
You just need to put the
Just switch the term.
Yeah. So this negative 10, let's bring it over there. So that'd be the same thing as 3x minus 5y plus 10 is equal to 0. Okay, so those two are definitely the same, right? Now, let's deal with this one. What would we want to do with this one?
And change it from the fraction to this.
We don't do decimals during this, right?
Yeah, the rid of multiply it by 5.
Yeah, exactly, right? Let's change this into general form, right? And then we can see if it's the same. So, again, I just don't like that 5 in the denominator, so I'm going to multiply everything by 5. So this will be 5y is equal to, And then the 5's cancel, so that's just x now. And then plus 10. Okay, and then, yeah, these don't look like they're the same line, do they? Okay, I probably should have had this worded different. Yeah, so, and then in this case, so we'll rearrange it again. So we'll get x on its own. We'll bring these ones over there. So we get 0 is equal to x minus 5y plus 10. So these ones actually aren't the same line, right? Because there should be a 3 in front of the x like the other two.
Just multiply by 3.
But then you have to multiply everything by 3. And then it still wouldn't work out. Yeah. Okay, so those were not the same line. Just know, though, we could have done anything there. We could have changed these ones into slope form as well. Or, I mean, yeah, slope intercept. Okay. Next one. Determine the x and y intercepts of the line whose equation is that one.
Is the y-intercept 3?
So let's do, so we'll say y-intercept. Now, if I'm looking for the y-intercept, I'll write it one more time. X plus 3y plus 9 is equal to 0. So if I'm looking for the y-intercept, something's equal to 0, right? You guys remember that? What would be equal to 0 here?
0.
If I'm looking for the y-intercept. Your x, right? Because on the y, if I'm on the y-intercept, then my x value would necessarily be 0. Okay, so I can just throw a 0 in for x. So 0 plus 3y plus 9 is equal to 0. So that 0 just cancels, right? Okay, so a little bit of algebra. I'm going to just subtract 9, subtract 9. So we get 3y is equal to negative 9. And then just divide both sides by 3. So y is equal to negative 3. Okay, and then we really should write this as a point, though, because it says what are the x and y intercepts? So then the point there would be, what would the point be?
0, negative.
Yeah, 0, negative 3. Okay, and I wrote that in a really awkward place, so now I'm going to be squished. Okay, so let's do it again now. So now we're going to look for the x-intercept. So for the x-intercept, something's going to be equal to 0 again.
Y.
Yeah, the y is going to be 0, right? So here, I'll just write it out again. So x plus 3y plus 9 is equal to 0. So x plus 3 times 0 plus 9 is equal to 0. And if you wanted to, I wrote all that, but yeah, you could have crossed that out right off the bat or at that point, right? Because anything times 0 is 0, right? So that whole term gets canceled. So now we've just got x plus 9 is equal to 0. So then we'll just bring the 9 to the other side or subtract it. So then we get x is equal to negative 9. So this point would be at negative 9, 0. Yeah. Okay, so now if we're going to graph this line, we should make our axis in the right place, right? So if my x-intercept is going to be at negative 9, I definitely got to leave enough room, like on this side, right? So I'm going to want my x-axis, or my, you know, my Cartesian plane to be, I don't know, even over here. Yeah, and then this one doesn't really matter. It's at, you know, negative 3. So as long as I have 3 below my next line there, so maybe, yeah, right in the middle, like you said. And then we can plot it. So 0, negative 3 was my y-intercept, so right there. And then my x-intercept was at negative 9, 0, so over there. And then with your straight edge, do a better job than I'm going to do. And then technically, would I go through these dots or would I just connect them?
Yeah, connect them.
I'd actually go through. This equation here is for this line, right? I found those 2 points on this line, but that line actually goes forever, right? That will go forever in either direction. So we should go through those 2. What's that?
Shouldn't the dots be open?
They would be open if it didn't include those points, right? If you remember, like the open dots, yeah. So it's closed. It actually does include that point as well. So we'll make it a closed dot. All right, last one. We'll just do this one and we'll be done. Okay. However you pronounce that, is making a ribbon shirt. She has 60 centimeters of ribbon that she will cut into 5 pieces with 2 different lengths. 2 pieces have the same length, and the remaining 3 pieces also have the same length. Generate some data for this relation showing the possible lengths. Graph the data. You know what I'm going to do? I actually think it's going to be easier to make the equation first and then use that to kind of make our data. So looking back on this, so she has 60 centimeters of ribbon, and you'll have 2 of a certain type of length, and you'll have 2 of another kind of, 3 of another kind of length, yeah. Anyone, I'm just going to give you guys a second. Can you guys write out an equation for that? So, I think I'd do something that kind of looks like this. Well, maybe this is a good place too. What's it all going to be equal to, like the length of the ribbon? 60, right? So I know this part. That's going to be like my constant term from before. So how is this next part going to go? Okay, so anybody have any idea for this first part? Yeah.
I wrote 60 equals 2x plus 3y.
2x plus 3y. Perfect, right? Nice. So yeah, and what does x represent in this case? Yeah, one of the lengths, right? Because they're 2 different lengths. And y would represent the other length, right? So there we go. There is my equation. I should be able to actually graph this data to make this work out, right? So, to tell you the truth, the way I would like to do this if I was going to graph this thing is I typically like slope-intercept form. It's the most useful. Like we use that one quite often. So let's change this thing into slope-intercept form and then see if we can just graph it, and then we'll be done. Okay, so slope-intercept form, we want it to be y is equal to mx plus b. So what I'm going to do here is just bring the 2x over. So minus 2x minus 2x. So we've got 3y is equal to, I'm going to write the 2x out front. I like my x term to be first. So 2x plus 60. And then we're just going to divide everything by 3. So we get y is equal to negative 2 over 3x plus, and then 60 divided by 3 is 20. And that's really why I like this too, especially when we have to make our own plane, because now I can kind of see where my y-intercept is. I can kind of see what my slope is doing. So, all right, this thing has to cross at like 20, and then it starts going down, right? So, yeah, might as well just make like the plane like here. And then maybe just here. Okay. Then let's we can just start putting some numbers in for x here now too, right? So let's start off with 20 here. So let's make our graph go up by tens maybe. So 10, 20, 30. Or you know what? Even 5s. That'll make it look better. 5, 10, 15, 20. Okay. So we know that this thing starts here. So we got a point there. Now, we could at this point, you know, go down 2 over 3, down 2 over 3. That's going to be kind of messy, though, won't it? Like, just because we're not going to land, like, a nice point there, right? So, anything else we can do? What's that? Kind of what I'm getting at is probably the X-Intercept, right? Like, what if we find the X-Intercept? It's probably going to land on, like, a nicer number, and then just connect the dots. So we can do that too, right? So, all right, so finding that would just be 0 for y is equal to negative 2 over 3x plus 20. Okay, and then we're going to subtract 20. So we've got negative 20 is equal to negative 2 over 3x. What do I do from here? Yeah, so what I'm going to do is just one at a time. I'm going to get rid of the 3. So I'm just going to multiply both sides by 3. So times 3 times 3. So we get negative 60 is equal to negative 2x. And then we'll divide both sides by negative 2. Divide by negative 2. Divide by negative 2. So those cancel. They ran out of the room. But we ended up getting 60 divided by 2, so we got 30 for x. So then if we go up by 5s on the x-axis too, we should be good here. Okay. And then where would we make a dot? Yeah, right here. So this thing crosses nicely there, right? And then we would, well, so now this one, would we continue the line through or would we connect the dots?
No, we connect the dots.
Yeah, we would actually just connect the dots on this one. Why is this one different?
Because it gives you like a distinct length.
Yeah, and
It's not continuous.
this is a real world situation, right? Where, remember what this is. This is my, like, these are my x's and these are my y's, right? Am I allowed to have a negative length? No, that wouldn't make any sense, right? So it has to stop at 0, right? And with my y's, I'm not allowed to have negative length either, so it's not allowed to go below 0 in the y's. So in this case, they would just connect. They'd start there and end there. Yeah. Okay, that's it.